Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as stationary waves. We want to do numericals of stationary waves. Please take down a sonometer wire of length 35 centimeters, a sonometer wire of length 35 centimeters is in unison with a tuning fork. Find the frequency of the fork. If the tension is 10 kg weight, and the mass per unit length is 10 to the power of minus 4 kgs per meter. Simple, straightforward. Frequency is 1 upon 2L square root of T by L. All the data is given to you. You have to just multiply this. The answer for this sum should be 1414 Hertz. Next, take on next sum please. A sonometer wire has a length. Of 90 centimeters. A sonometer wire has a length of 90 centimeters. Fixed horizontally and under constant tension. Where should the bridge be placed below the wire? So that the two segments emit notes which are in the frequency of 2:1. So that the two segments emit notes which are in the whose frequencies are in the ratio of 2:1. Let's assume that this is the knife edge or this is the bridge. This part of the length is say L1 and this part is say L2. Right? Now I can say that L1 and L2 be the lengths of the two segments. In that case, I can therefore say that L1 plus L2 is 90 centimeters. Right? Now I can use by law of length. Law of length says that N1 L1 should be equal to N2 L2. Frequency into length is constant. Therefore, N1 upon N2 is going to be L2 upon L1. But N1 upon N2 is nothing but 2 upon 1 is L2 upon L1. Therefore, I'll get L2 is twice L1. I can substitute this value. In the equation of length. So I can say L1 plus L2. L2 can be written as twice L1 is 90 into 10 raised to minus 2. Thrice L1 is 90 into 10 raised to minus 2. L1 is equal to 30 into 10 raised to minus 2 meters. Therefore, L2 will be 60 into 10 raised to minus 2 meters. Next, take on next sum please. A stretched sonometer wire, a stretched sonometer wire is in unison with a tuning fork. A stretched sonometer wire is in unison with a tuning fork. Is in unison with a tuning fork when the length is increased by 2%. When the length is increased by 2%, the number of beats is 5 per second. The number of beats is 5 per second. Find the frequency of the tuning fork. Let's assume that L1 is the initial length of the wire, right? So L2 will be L1 plus 2% of L1. So in that case, L1 plus 2 upon 100 into L1, that's 102 upon 100 L1, right? Once I have this, they've given you that let N1 and N2 be initial and final frequency. Then I can say by law of length, says that N1 L1 is equal to N2 L2. So in that case I can say that N1 upon N2 is L2 upon L1, but L2 we know is 1.02 L1 upon L1. Therefore you can say that N1 is 1.02 N2, right? Now they are saying that now from this it's very clear that N1 is going to be greater than N2. I can say therefore N1 is greater than N2. Beats is larger frequency minus smaller frequency, therefore N1 minus N2 is 5, but N1 can be written as 1.02 N2 minus N2 is 5, 0.02 N2 is 5, N2 is 5 upon 0.02, 5 upon 2 into 100, right? So you will get your answer. You will get your frequency. N2 will be nothing but 250 Hertz and N1 will be N2 plus 5, so 255 volts. Next, take on next one please. A sonometer wire 60 centimeters long. A sonometer wire 60 centimeters long produces resonance with tuning fork. When the length is decreased by 5 centimeters, when the length is decreased by 5 centimeters, 10 beats per second are heard. 10 beats per second are heard. Find the frequency of the tuning fork. Let N1 and N2 be initial and final frequencies. Therefore, I can say by law of length says that N1 L1 is equal to N2 L2. So in that case I can say that N1 upon N2 is nothing but L2 upon L1. So N1 upon N2 is nothing but L2, 55 into 10 raised to minus 2 upon 60 into 10 raised to minus 2. So in that case I'll get N1 is 55 upon 60 N2, right? So in this case I can therefore say that N1 is less than N2 because the numerator is smaller. Beats is nothing but larger frequency minus smaller frequency, therefore N2 minus N1. Beats, how many beats are heard? They're saying 10 beats are heard. So N2 minus N1, N1 is 55 upon 60, N2 is 10. After this you can solve and get the answer. You should get the answer for this as answer N1 is 110 Hertz. Next, two tuning forks produce 5 beats per second. Two tuning forks produce 5 beats per second when sounded together. One of them is in unison. One of them is in unison with a 90 centimeter sonometer wire, while the other with 91 centimeter sonometer wire. Calculate the frequencies of the forks. Let N1 and N2 be the frequencies, right, of the fork. Now in that case I can straight away apply law of length. If I apply law of length says that N1 L1 should be equal to N2 L2, N1 L1. So N1 upon N2 should be equal to L2 upon L1, which is nothing but 91 upon 90. 10 raised to minus 2 will get cancelled. So I'll get N1 is 91 upon 90 N2. Since the numerator is larger, therefore I can say that N1 is greater than N2. Beats is larger frequency minus smaller frequency. How many beats they are saying are heard? Beats, 5 beats. So this can be written as 91 upon 90 N2 minus N2 is equal to 5. You can solve after this and get the answer. The answer for this should be N1 is 455 Hertz. Right. Next, take down next one please. A tuning fork produces 6 beats per second. A tuning fork produces 6 beats per second with a sonometer wire which is either 95 centimeters long or 100 centimeters long. Find the frequency of the tuning fork. Find the frequency of the tuning fork. Find the frequency of the tuning fork. Let N1 and N2 be the frequencies of the N1 and N2 be the frequencies of the wires for the corresponding length. right? In which case I can say that I can apply law of length. If I apply law of length, I could say that by law of length, N1 L1 should be equal to N2 L2. N1 upon N2 is L2 upon L1, right? So in that case I can say that N1 upon N2 is L2 100 upon 95. Therefore I can say N1 is 100 upon 95 N2. Now they are saying that 6 beats per second are heard with the sonometer wire, right? Now let's assume that let N be the frequency of tuning fork. If N is the frequency of the tuning fork, we know that from here N1 is greater than N2. Hence the frequency of the tuning fork has to be in between them, only then beats per second will be heard with both the lengths of the wire, right? Now we know that beats are nothing but larger frequency minus smaller frequency. So N1 minus N is, they are saying 6 beats per second are heard. Also N minus N2 is also 6 beats per second, right?
Like N is equal to frequency.
Sonometer wire. I'm going to hit the tuning fork here. I'm going to hear 6 beats per second. I'm going to hit the tuning fork here. I'm going to hear 6 beats per second, right? That means this sonometer wire is going to vibrate with some frequency, say N1. This sonometer wire is going to vibrate with some frequency, say N2. The tuning fork is vibrating with some frequency N. The tuning fork, if I hit it, that means the tuning fork is vibrating with some frequency. If I hear 6 beats per second with one length of the tuning fork, beats is nothing but the difference between the frequency. Now, from here it is very clear that N1 is going to be greater than N2. So N1 is the largest frequency, right? If I'm hearing beats per second with the tuning fork, that means N1 minus N should be 6 beats per second. Similarly, N2 is the smallest frequency, that means the frequency of the tuning fork minus the frequency of the second length should be 6 beats per second, right? Now, I can say that therefore N1 is N plus 6. I can also say that N2 is N minus 6, right? But they have given me that, but we've already found out that N1 upon N2 is 100 upon 95. So that means N plus 6 upon N minus 6 is 100 upon 95. The only unknown in this equation is N. You should be able to get the value of N. You will get your frequency of the tuning fork, right? The answer for this sum should be N should come to 234 Hertz. Next, let's take the next sum, please. Two similar sonometer wires produce 2 beats per second. Produce 2 beats per second. The length of one is 50 centimeter and the length of the other is 50.1 centimeter. Calculate the frequencies of the two wires. Calculate the frequencies of the two wires. Calculate the frequencies of the two wires. Let N1 and N2 be the frequencies of the two wires. In that case, I can say that by law of length says N1 L1 is equal to N2 L2. That means I can say that N1 upon N2 is L2 upon L1, L2 50.1 upon 50. That means I can say N1 is 50.1 upon 50 N2. Therefore I can say that N1 is greater than N2, but B is larger frequency minus smaller frequency. So N1 minus N2 is equal to, how many beats are you hearing? You are hearing 2 beats per second. So I can therefore say that N1 50.1 upon 50 N2 minus N2 is 2. Right? And then you should be able to get the answer. The answer for this sum should be N1 should be 1002 Hertz. Next, take down next sum please. A sonometer wire is stretched. A sonometer wire is stretched by a weight of 4 kgs. By a weight of 4 kgs. And gives a frequency of 256 Hertz and gives a frequency of 256 Hertz. What weight will produce an octave of this note? What weight will produce an octave of this note? A sonometer wire, when stretched by a weight of 4 kg, gives a frequency of 256 Hertz. What weight will produce an octave of this note? What weight will produce an octave of this note? Octave, that means the given frequency will be twice the fundamental frequency. That's the meaning of octave. Now I can say by law of tension, frequency is directly proportional to square root of tension. In that case, I can therefore say that N1 upon N2 is square root of T1 upon T2. The only unknown here is T2. I should be able to get the answer for this, right? I have T1, I have N1, N2 can be substituted as 2N1 and I'll get my answer. The answer for this sum should be T2 is equal to, answer, T2 is equal to 16 kg weight. Next, take down next sum please. Two strings of the same material, and same cross section are suspended on sonometer. One is loaded with 12 kg. One is loaded with 12 kgs and the other with 3 kg and the other with 3 kgs. The first string is tuned to the second harmonic of the second string. The first string is tuned to the second harmonic of the second string. If the length of the first string is 100 centimeters, if the length of the first string is 100 centimeters, what is the length of the other string? Now, since the two strings are made of same material and cross section and have same cross section, therefore their linear densities will be equal. That is, M1 will be equal to M2. Now, tension on the string or frequency of the string is given by 1 upon 2L square root of T by M. Similarly, N2 is 1 upon 2 L2 square root of T2 by M. Right, divide equation 1 and 2. Divide, so I'll get N1 upon N2 is 2 and 2 gets cancelled, L2 upon L1 into square root of T1 upon T2, right? Out of which T1, T2 I know, T1, T2 I know, N1 I know, N2 I know, L1 I know, L2 is the only unknown that I have. I should be able to get the answer for this. The answer for this should be L2 is 1.5 meters. Next, take on next one please. A movable bridge divides the sonometer wire. A movable bridge divides the sonometer wire into two parts which differ in length by 1 centimeter. A movable bridge divides the sonometer wire into two parts which differ in length by 1 centimeter and produce 4 beats per second. The whole length is 100 centimeters. The whole length is 100 centimeters. Find the frequency of the two parts. Let L1 and L2 be the lengths of the two parts. That means I can say L1 plus L2 is 100. L1 minus L2 is 1. The total length is 100. They differ in length by 1. That means I can say 2L1 is 101. L1 is 50.5. Therefore, I can say that L2 will be 49.5. Right? Now, let's assume that let N1 and N2 be the frequencies. So, in which case I can say by law of length, if I apply law of length, I'll get N1 L1 is equal to N2 L2. N1 upon N2 is L2 upon L1. So I'll get N1 upon N2 is L2. 49.5 upon 50.5. So I'll get N1 is 49.5 upon 50.5 into N2. Once I have this, I can therefore say that N1 is less N1 is less than N2, beats are larger frequency minus smaller frequency. You are going to hear 4 beats per second. So instead of N1, I can say 49.5 upon 50.5. N2 is 4. You can solve the sum after this and get the answer. The answer for this should be N1 should be 202 Hz. Next, take down next sum please. A sonometer wire is in unison with a tuning fork. A sonometer wire is in unison with a tuning fork when stretched by a weight of specific gravity. When stretched by a weight of specific gravity, nine. If on completely immersing the weight in water, the wire produces 5 beats per second. Calculate the frequency of the fork. Let N1, T1, N2 and T2 be the frequency and tension in air and water. Right? Now, I can say that since the two wires are made up of, have the same length and linear density, I could say that since the two wires have same length and linear density, since they have the same length and linear density, that means their length and linear density will be constant. Therefore, I can say that L and M are constants. Once I have this, I can say that N1 is equal to 1 upon 2L square root of T1 upon M. Similarly, I could say that N2 is 1 upon 2L square root of T2 upon M. Divided the two equation, I'll get N1 upon N2 is square root of T1 upon T2. Right? Now, the body is going to be immersed in water. See guys, this is the bridge, this is your sonometer wire. This is the weight that is attached to it. And here you have a beaker and the body is immersed in water. Now by Archimedes's principle, when a body is immersed in water, it loses weight. Right? That means if body is going to be immersed in water, it loses weight. That means I could therefore say that T2 is going to be less than T1. Right? If T2 is going to be less than T1, but we know that N1 upon N2 is nothing but square root of T1 upon T2. Therefore, I can say that N1 is equal to square root of T1 upon T2 into N2. Now since T1 is greater, that means N1 is going to be greater, right? I can therefore say that N1 will be greater than N2. If N1 is greater than N2, beats is larger frequency minus smaller frequency. That means N1 minus N2 should give me the beats, requisite beats. 5 beats are larger frequency minus smaller frequency. In which case I could say that N1 plus 5 is equal to N2, right? Now, in that case, N1 upon N2 is square root of T1 upon T2. We just found out N1 upon N2. N2 can be written as N1 plus 5 is square root of T1 upon T2.
N1 minus 5 is
Minus. Right? Now, once you have this, then I can say that specific gravity is given by the formula weight in air upon loss of weight in water. Weight in air upon loss of weight in water. Right? So in that case I can say that 9 is weight in air T1. Loss of weight in water is going to be T1 minus T2. Loss of weight in water is going to be T1 minus T2. So in that case I can therefore say that 9T1 minus 9T2 is equal to T1. So I could say that 8T1 is equal to 9T2. I'll get T1 upon T2 is nothing but 9 upon 8. Once I have this, I can substitute this in the above equation and say that N1 upon N1 minus 5 is square root of 9 by 8. Right? T1 upon T2 I have substituted. Now N1 is the only unknown frequency. You should get the answer for this. You will get the answer for this as N1 is 87.22 Hz. Next, take down next one please. In Melday's experiment, when the string is stretched by a weight, when the string is stretched by a weight of 10 grams, four loops are obtained. 4 loops are obtained. What weight should be used to obtain 7 loops? What weight should be used to obtain 7 loops? What weight should be used to obtain 7 loops? Now for Melday's experiment, I can say that Pp square is constant. That means I can say T1 P1 square should be equal to T2 P2 square. T1 I have, T1 P2 I have. I can easily find out T2 here. I should get the answer for this as T2 will be equal to 3.26 grams. Answer T2 is 3.26 grams. Next, take down next one please. In Melday's experiment, the number of loops on a string change from 5 to 6 from 5 to 6, sorry, from 5 to 4. Change from 5 to 4 by an additional weight of 0.018 kg weight. By an additional weight of 0.018 kg weight. Find the initial tension on the string. Find the initial tension on the string. For Melday's experiment, I can say that Tp square is constant. Therefore, I can say that P1 square is P2 square. Again, all the values I have, I can substitute. This is T1 into 25 is T2 can be written as T1 plus 0.018 into 16. T1 is the only unknown. You should get the answer for T1 here. The answer should be T1 is 3.2 into 10 raised to minus 2 kg weight. Next, take on next one please. In Melday's experiment, the tuning fork is arranged in perpendicular position. The tuning fork is arranged in perpendicular position and 6 loops are formed. When the length is 1.5 meters, stretched by a weight of 10 grams. If the mass of the string is 9 into 10 raised to minus 5 kgs, if the mass of the string is 9 into 10 raised to minus 5 kgs, calculate the frequency of the fork. Calculate the frequency of the fork. In Melday's experiment for perpendicular position, I can say that frequency n is nothing but it's given by the formula P by 2 L upon square root of T by M. P, L, T, M, all the values are given to you. Straight multiplication. Answer for this should be 80.83 Hertz. Next, take on next one please. In Melday's experiment, the tuning fork is arranged in parallel position. In Melday's experiment, tuning fork is arranged in parallel position and is stretched by a weight of 4 into 10 raised to minus 3 kgs. If 4 loops are formed, and the length of the string, if 4 loops are formed and the length of the string is 80 centimeters, the length of the string is 80 centimeters. In Melday's experiment, the tuning fork is arranged in parallel position and the string is stretched by a weight of 4 into 10 raised to minus 3 kgs. If 4 loops are formed and the length is 80 centimeters, the length is 80 centimeters, calculate the frequency of the fork, if the linear density is 9.8 into 10 raised to minus 5 kgs per meter. Now, in Melday's experiment for parallel position, frequency is given by the formula P by L square root of T by M. Again, I have all the values. I can solve this and get the answer. The answer for this should be 100 Hertz. Right? Okay. We'll stop this here for the day. Thank you very much.